So this is the solution for steel framing system. We have total deformation and beam tools. Beam tools consists of direct stress, minimum combined stress, and maximum combined stress. So, like this. Okay, let's begin to design this. Okay, for the first, click on static structural for analysis systems. Okay, click on geometry. Make it sure line bodies active. Back to geometry. Double click. After that, we're gonna go to sketching. Click on setting. Make grid spacing. Make it sure show in 2D and channel active. Major grid spacing, I choose by method and minor step. For major 5. Okay, click on draw. Okay, start draw. Click on line. Draw like this, and then here, and connect here, and connect here, and the last one connect here. Okay, we have the system. Click ISO. Okay, to make this line 3D, we're gonna go to line from sketch at first and click on XY plane, click sketch 1. Okay, great. Okay, now we have one part, one body here. After that, we're gonna go to create, click pattern to make this 3D model. For geometry, click here, directions, click Z-X plane. Okay, click this axis, click here and apply. For offset, choose 6 meters for examples, and then generate. Okay, we have to connect this part and this part. Okay, now we have 2 part and 2 body, and then we have to connect. Okay, click concept, click line from points, and then connect here to here, here, and then here. Okay, apply. Okay, we have 6-point segment. Okay, and generate. Okay, now we're gonna go to view and make it active cross sections solid. Okay, now we're gonna go to concept, cross section, and choose I sections. So fill out dimensions. For example, I choose this value. Okay, generate. Okay, click on line body, move to line body, and then choose cross sections. Replace cross section to I1 or I sections. Okay, now we have this, and I forget that to show you. to click on cross section solids. Okay, don't forget it. After that, because I-beam in the above structure are used as H-beam, so to fix misaligned cross sections, we gonna go to H, and then choose H line. I show you. Okay, click here, 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 and here. And then for rotate to their neutral axis, choose 90 degree. Okay, after that we're gonna go to model. So this is the model, and then click on geometry. Okay, click on line body, and for the material on assignment, make it sure this is structural steel. Okay, we're gonna go to replace element size. Let's use this value for example, and then generate. Okay, this is. Okay, this is for the result for mesh after meshing. Okay, and then click on static structural. Click fix support. Okay, and then click node. Okay, okay, after that click here, rotate here, and then click node here to make it fix support. Okay, we have 6 vertex or 6 nodes for geometry from fix support. Okay, click ISO to bed, and then click on static structural. Right click. Okay, after right click, click on line tracer. Okay, click on line tracer and click this line. Okay, apply to one edge for geometry. Okay, for define by, replace a component, and then fill out this Y component. Okay, after that we have to repeat the ways just now, and click right click on static structural and click on line tracer. Click here, apply, define by, we choose component, we fill out this again. We have to make 7 line tracer. And then for the last one, Okay, after that, now we have this 7 line freezer and 1 support. Okay, we move to solutions, click insert, click deformation, click total, and click insert, click beam tools. Okay, after that we must to solve this problem. Okay, click solve. Okay, now we have solution for total deformation. So this is the solution, and I show you the graph, the animation. And then we have to move to beam tools. Okay, we have direct stress, minimum combined stress, and maximum combined stress. Okay, we have to move to beam tools. Okay, for the beam tools we have direct stress, minimum combined stress, and maximum combined stress. Okay, click on direct stress. We see the animation. The minimum combined stress and then the maximum. So you can see the solution or the value for maximum combined stress, minimum combined stress, direct, and total deformation from here. Okay, this is a problem and solution for today. Thank you so much, and then don't forget to subscribe and like. Thank you.